Hello, this video covers 10 misunderstandings about the two-step transformation. It is a response to criticism. As you can see from these histograms, the two-step approach that is the center of this discussion first transforms an original variable toward uniformity using a fractional rank, and then based on those values, it applies the inverse normal function to achieve normality. To provide some background, the two-step, as we call it, was first described in a 2011 article in Communications of the AIS. To date, that article has over 500 Google Scholar sites across many disciplines. In the same year, a video was uploaded to YouTube, which has now been viewed over 100,000 times across the world. This video explains how to perform the procedure in SPSS. In 2017, Dr. Burney and I published an article in the Journal of Information Systems that empirically evaluated the two-step using real accounting data. The following year, JIS allowed a criticism of our paper, published by Ronco and Aguirre-Ureta. And then in 2021, another article was published in the Database for Advances in Information Systems, showing that the two-step can affect our understanding of theories. This video is a response to the authors that criticized our work. In this video, I will refer to them as the authors. Before the authors published their criticisms, we were assured by a co-editor-in-chief of JIS that we would be able to respond. Unfortunately, a written JIS editorial policy allowing authors of critiqued original articles to respond was ignored, and our response to criticism was rejected by JIS. This is our response. Note also that each slide showing the author's criticism has a blue line. Above that line is the criticism, and below it is our response. It's important to note that the 10 misunderstandings identified here is in no way an exhaustive list. We observed problems on literally every single page of the author's critique. We would like to respond to the first misunderstanding by stating that non-normality is a substantial problem in AIS and other IS research. You can see 3 quotes here by the authors suggesting that non-normality is not a problem. First, quote, "One could question whether the consequences of non-normality have been exaggerated," close quote. Another example is, quote, "The non-normality of the error term is rarely an important issue for applied research," close quote. A third example is where the authors state, quote, "Normality is largely a non-issue for statistical inference based on OLS estimates," close quote. We would like to emphasize the extreme non-normality facing many accounting and AIS researchers. Good examples are found in our 2017 JIS article. Among the 45 corporate financial performance variables that we evaluated, kurtosis was greater than 400 for all of them. By contrast, the standard for kurtosis being problematic is 2 in the behavioral sciences. We assert that such will impact the assumptions of statistical tests using linear interpretations. Regarding the second misunderstanding by the authors, we assert that univariate transformations are justifiable and useful. These quotes by the authors are too critical of univariate transformations. The authors state, quote, "Statistical transformation can only destroy but not create new information in the data," close quote. In addition, quote, "The two-step transformation is information destroying," close quote. By contrast, in the same article, they also advocate transformations. They advocate ranks, the natural log, and non-parametric techniques, which always involve distributional transformations, oftentimes ranks. We should accept that all transformations change distributional shapes, not just the two-step. The authors cite McKay, 2003, to support their idea that transformations are information destroying. However, McKay's lone mention of information destroying is not in the body of the text, but part of an end-of-chapter exercise for students that you can see on the slide. McKay also guides readers to transform data using the natural log, power, and Gaussian or normal transformations. Transformations do not destroy information, rather they provide researchers with additional information, expanding their empirical choices. The researchers also borrow heavily from Wooldridge, citing his econometrics textbook 10 times. Here is an example. The authors state, quote, "No normality assumptions are made about the explanatory variables, and sample sizes are typically large enough that non-normality of the error term is hardly an issue," close quote. Wooldridge spends a good deal of time explaining asymptotic normality and whether or not regression is robust to non-normality. However, Wooldridge does not definitively say that transformations are a bad thing. In fact, he says there is no rule of thumb for sample sizes, and there are two other situational factors that impact the usefulness of linear tests. These are the distribution of error terms and degrees of freedom of the test. Given that we have no hard and fast rule of thumb about sample size, it seems reasonable that in order to enhance the usefulness of linear tests, one should transform variables to mitigate non-normality, since according to Wooldridge, this is one of the three factors impacting the usefulness of linear tests. This is because the distributions of univariate predictors is related to the distribution of error terms. Also note that statistical power is calculated using effect sizes, which will rely on the distribution of independent variables in the analysis. This is a very brief summary of Wooldridge, but we advocate understanding the full meaning of his work. In response to the fourth misunderstanding that we have identified, we argue that univariate and multivariate normality are related. The authors seem to argue that the two concepts are not associated. They allude to this when they say, quote, "A univariate normality does not imply multivariate normality," close quote, when in fact we found 3 textbooks on statistics saying the opposite. In one example, Myers, Gamst, and Garino state, quote, "The assumption of multivariate normality, although somewhat more complicated, is intimately related to its univariate counterpart," close quote. Adair, Hand, and Mellenberg state, quote, "Normality of the dependent and independent variables is a sufficient condition for the normality of the residuals," close quote. And third, Keenan, Petuch, and Stevens state, quote, "If univariate normality does not appear to hold, we know then that the multivariate normality assumption is violated," close quote. In research projects where non-normality is bad enough, the two-step and other transformations may very well address the correct problem in changing univariate distributional shapes, since they are related to multivariate distributions. Fifth, the authors criticize the two-step by saying that it is impossible to back-transform its results. The authors state, quote, "Back-transforming the predictions to the original metric as done above is impossible," close quote. However, this is common of many transformations. The entire class of non-parametric procedures are commonly used and even encouraged by the authors without concerns for back-transforming. Also note that back-transforming has conceptual problems. It is complex when original data has been preconditioned, such as when we need to shift values to avoid applying it to negatives or zeros, which will result in missing values. Also, back-transforming is controversial as original and transformed data distributions differ. Finally, note that the two-step is arguably more amenable to back-transforming, since it never requires preconditioning before being applied. That is, it can be applied to negatives and zeros, and it's the only transformation we know about where the mean and variance arguments are set by the researcher. In other words, the researcher can set the units of measurement, thus often diminishing the need for back-transforming. Sixth, the authors seem to confuse nonlinear and linear regression. This confusion is evident in several places. For example, they encourage researchers to switch from nonlinear to linear models through univariate transformation. They state, quote, "A typical remedy for nonlinearity is to linearize the model by transforming the variables," close quote. They then advocate the natural log univariate transformation for this purpose. They are different classes of regression. Linear regression attempts to fit predicted values on a straight line, whereas nonlinear regression attempts to find a curve or parabola that fits the data, so you can't always anticipate the shape on which predicted values will be fit. In addition, therefore, when we use transformations in linear regression, that does not mean we are changing to nonlinear regression. In another example, the authors imply that fractional polynomials are nonlinear models, as shown in the yellow highlighted text. In fact, fractional polynomials are used in linear models, and we don't linearize models with transformation. We use either linear or nonlinear techniques. Just because we use power, polynomial, or quadratic transformations as suggested by the authors does not in any way change how linear regression results are interpreted. In fact, when the authors suggest linearization of a model, often this can be best achieved using the two-step, which when applied can result in relationships having associations that appear more linear. Here is another example where the authors seem to imply that linearity and normality are mutually exclusive. In fact, they are related. The authors also argue that the two-step somehow obscures relationships using original data. The authors claim, quote, an appropriate explanation for the data goes unnoticed when the two-step transformation is used, close quote. In another example, they state that, quote, misspecification is masked by the two-step transformation, close quote. This is counterintuitive because transformations do not cause findings to go unnoticed. They actually attempt to mitigate misspecification, and in fact, using original untransformed data can cause model misspecification. The only way that a researcher would miss relationships using original data is if they never inspect it in the first place. We know of no transformation that advocates deleting original data or forgetting observations regarding their relationships. Seventh, the authors use very weak analyses that obscure the actual meaning of statistics. They make sole use of simulated data based on chi-squared distributions. Look on the right-hand side of this slide. The simulated chi-squared distribution on the top right and the histogram of a real financial ratio on the bottom right are both right skewed. However, normality diagnostics expose extreme differences, and those diagnostic differences will greatly impact test assumptions and results. The authors also use a normality diagnostic, i.e. shift, to make points. They use very clean quadratic relationships, again based on simulated data. They also use sample of one scenarios. All of these practices are extremely limited and not generalizable to real data sets used by AIS researchers. By contrast, real data is often far more non-normal than chi-squared simulated data. The data used by the authors is much more clean and continuous than the vast majority of financial ratios used in AIS research. Also, their sample of one scenarios are encapsulated within our results because we use samples in many tests. For example, the single antidote that they depict in their Table 1 is already a part of our results in Table 2, Panel A. Eighth, methods should be compared before judging its relative merits. The authors imply that they made such comparisons when they state, quote, based on the analysis presented in this article, it is difficult to see a scenario where the proposed two-step transformation technique would be preferable over these alternative techniques. Close quote. Before the authors discard the two-step as a useful technique, they should have compared it. Reading their text, it appears as though they did compare the two-step technique to others, but they did not. To the contrary, the authors made no comparisons between the two-step and any other technique. In the absence of comparisons, as far as we know, the assumptions of any given statistical test may very well be best achieved using the two-step normality transformation, and such comparisons should be done using realistic data distributions actually faced by accounting researchers to be more meaningful and generalizable. The ninth misunderstanding involves models containing transformed variables. There are several examples of this. First, the authors state, quote, OLS without any transformation produces an accurate estimate of the population regression coefficient, close quote. In addition, the authors' Monte Carlo replications are supposed to demonstrate that the two-step, quote, increases the variance of estimates, close quote, decreases the precision, close quote, and, quote, produces variance estimates that are severely negatively biased, close quote. They also talk about shift, concluding that the two-step, quote, introduces new problems for both statistical inference and interpretation of the results, close quote, and that it results in, quote, overstating test-retest reliability, close quote. Again, note that they don't compare the two-step to other procedures, and they ignore the fact that models with and without transformations are simply separate models, the existence of which is beneficial to researchers. Look at what Geffen, Rigdon, and Straub said about SEM models in a 2011 MISQ article. The results need to be interpreted accordingly because the slope of the relationship between y and the natural log of x is not the same as the slope of the relationship between y and x. In other words, the two models should be interpreted differently because they have different terms. This is common practice across statistics. Being availed uniquely different models does not obscure meaning. Think of the Box-Cox procedure, which can make infinite versions of a variable, from which the researcher can choose the best transformation. This practice does not in any way diminish the usefulness of these different options to researchers. Transformation choice is an empirical, situation-dependent decision, according to Wooldridge, the author's favorite source. And 10th, we would like to assert that simply we should try to understand method studies and properly characterize the work of others. The authors use a weather example and try to argue that the two-step attempts to always detect the presence of an effect regardless of whether or not it exists. The authors state, quote, "Clearly, like a forecaster that will always say that the weather will be sunny regardless of what the actual weather looks like, a technique that will always indicate the presence of an effect regardless of whether the effect exists in the population is not a useful technique." Close quote. But our research consistently shows that the two-step may not always detect an effect. For example, if you look at Table 2 in our study, the two-step resulted in significant results in 96.8% of the tests performed using Pearson's correlation coefficient. In this example, 3.2% of the tests were insignificant. This is one way our study acknowledged that the two-step varies in its results. In fact, in all of the test summaries we provided, the two-step varied in its efficacy and sometimes yielded insignificant results. Because the two-step produces correlation effects that are on the average higher than other techniques, in no way should be interpreted that it will always indicate the presence of an effect. We never asserted that the two-step always produces results desired, and we know of no transformation that does that. There are several other examples of this, where the authors try to contrast reality with what we said. In this sentence, they state that correlations can show opposite results when in fact there are no contradictions in our results, which are based on real, extremely non-normal data, large samples of tests, and diverse distributions. In other words, the evidence shown by the authors is not novel or contradictory to our study. In another example where the authors misunderstand our work, they cite two studies that they claim point to methodological explanations for the IT paradox problem. In fact, neither of these two sources mention non-normality or transformations. Further, the authors seem to contradict themselves when talking about the two-step and transformations. They say that the two-step contains only information about ranks, when ranking is only the first of two steps. And then they later advocate ranking. Note that non-parametric techniques often involve ranking, such as the Spearman's rank correlation coefficient. The authors claim that we never apply the two-step to simulated data, when in fact we used simulated data as a baseline and found something very interesting. We found that extremely non-normal financial ratios have effects similar to random data. Nonetheless, here the authors are wrong again. The authors also say that we proposed the two-step in our 2017 study, when in fact it was described and advocated in 2011 in CAIS, and in that study I acknowledged that it pre-existed. It had been used in a limited number of medical studies. So in conclusion, if you do not satisfy the assumptions of a test, you should make empirical modifications until you do. Otherwise, you cannot interpret the test in a standard way. So if you continue to struggle to satisfy the assumptions of a test, you should actually be encouraged to use the two-step. We hope this video is a reminder to remain critical in your reading of all peer-reviewed research, including methods critiques. Finally, we encourage journals to follow their written policies allowing criticized authors to publish responses, and to follow their policies in general. This video is an extended version of a TREO Talk as a part of the 2021 International Conference on Information Systems. It can be cited as shown in the highlighted text. Thanks for watching.